Hi, and this is lesson 7-6, and it's entitled Solve a System of Linear Inequalities. This is on page 466, and I would encourage you to start on that page first of your book. You might want to pause the video, go to page 466. Okay? We're going to start with some vocabulary again, as we always do, some important terms or phrases that you need to know that are pertinent to what we're doing in this section. And remember, a couple things in the title of this. If you don't know what a system of linear inequalities is, it's going to be hard to actually do what's being asked of you. So remember, a system of equations or inequalities, remember this is what we started off with in chapter 7 a couple weeks ago. A system means that we have two or more, and maybe I should add to this, it's two or more equations or inequalities that are linear. So that would mean two variables, and they have to have the same variables. And remember, if we're talking inequalities, that means we have a greater than, less than, or greater than equal to, less than equal to. So we're looking at solving a system of linear inequalities today, all right? Now, this might be disappointing, but I just got to be honest with you. The only way you can solve a system of inequalities is by graphing. Okay, elimination or substitution, which I am 100% positive you probably like elimination and substitution a heck of a lot better than the graphing method, and I would agree with you, I do too. But when it comes down to inequalities, elimination and substitution won't work, because elimination and substitution will only find the one point where the lines intersect. When we have linear inequalities, remember, if you go back to section 6-7, we'll talk about that in a minute. When you have a linear inequality in two variables, remember how we drew a line and had to shade a side of the line? There is more than one solution, so we have to solve these by graphing. So again, I'm sorry, we can't use substitution or elimination to solve these. Remember, a solution to a system of inequalities is an ordered pair that satisfies all inequalities in the system. The ordered pair can't work for one of the equalities, but works for a different one. Okay, it's got to work for both. If it does not satisfy each inequality, it's not a solution. All right, so those are some reminders, some vocabulary. So how do we graph a system of inequalities? Well, this would be a good time maybe to, again, pause the video for a minute and go back to section 6-7, which is on page 405. I'll just jot that down here, page 405, okay? This would be a good time if you forgot to go back and look at that, or go back to my section 6-7 video. If you do not know how to graph a linear inequality in two variables, you might want to take the time today to rewatch this video on section 6-7. So if you're new to the class second semester and you don't remember that, I would highly encourage you to take the 10-15 minutes it takes to watch this, because it's not super hard. It's a process. It's an easy process, but you have to know how to do it. Okay. So for the rest of you that remember this process, remember in section 6-7, I gave you a two-variable inequality. You graphed a line, either bold or dotted, and then that line's a boundary line. You plugged in 0, 0 to determine which side of the boundary line to shade. So when you graph a system of inequalities, you graph each inequality just as you did, but you hold off on the shading. You don't shade immediately. When you're done graphing each of the lines, you only shade the intersection of the shaded regions. In other words, you're only going to shade where they're in common. Now, I'm speaking that, I'm writing it in words here, and some of you are probably like, I'm not really sure what you're talking about. The best way I can teach you this is just to show you, okay? Talking you through it isn't probably the best way. I'm going to show you, and we'll do that right now. So let's actually show what I'm saying here. Let's go to problem 15, and problem 15 right now is on page 469. So again, you might want to pause the video real quick, go to page 469, okay? And in question 15, it says graph the system of inequalities. So I have two inequalities, and I want to graph these. So let's graph x less than 8. And remember, x equals 8, if we always pretend that it's equals first, x equals 8 would be the vertical line 8 units over. And remember, I'm going to draw a dotted line because there's no equals in here. Okay? So I'm going to draw a dotted line. There's no equal in here. Now, I'm not going to shade yet, okay, because I got to graph both inequalities first. But let's think about this. Let's try 0, 0. If I plug in 0 for x, there's nowhere to plug in 0 for y. Is this true? Is 0 less than 8? And the answer is yes, it is. So in my mind, I got to remember, I'm going to be shading over here left of this dotted line. Okay, so I'll get to that in a minute. But now I have to also graph the second inequality. X minus 4y less than equal negative 8. Now remember, this inequality here is in standard form. And if it's in standard form, then I should be able to find the intercepts real quick. So let's find the y-intercept. And to find the y-intercept, I plugged in 0 for x, which makes x disappear. That's covering it up. And negative 4 times 2 is going to give me negative 8. So that's why my y-intercept is 0, negative 2, which I can graph right now, and I will. There's 0, negative 2. And then to find my x-intercept, all I have to do is plug in 0 for y, which will cover up the y, and x equals negative 8. So x must be negative 8, and I can plot that point. So negative 8, 0. So I just graphed my two intercepts. Now I take my ruler out. I want to draw a bold line because you notice I have equals in here. I want to draw a bold line, so let's do that. And now let's think about shading this. If I try 0, 0, if I try 0, 0 and I want to shade this, okay, oops, I didn't want to do that yet. I just gave you the answer, okay. If I plug in 0, 0 and I try it here, 0 minus 0 is nothing less than or equal negative 8. And I'm thinking, no, 0 is bigger than negative 8, so I should be shading up here. So think about this for a minute. The first inequality told me to shade left of the dotted line. The second inequality told me to shade above the bold line. And these two are in common up here, so that's what I'm actually going to shade. Only where the two overlap. So left of the dotted line and above the bold line are in common up here, so that's what I'm going to shade. So what I just learned in number 15 is that any point on this bold line, I should say, left of the dotted line, or anything that's shaded up here is a solution to both inequalities. I could pick any point, like I could pick this point here. This point up here is 0, 6, and if I plug in 0, 6, let me unshade this for a minute. If I plug in 0, 6, if I plug in 0 here, it's true, and if I plug in 0 here and 6 here, I get negative 24, and that is less than or equal to negative 8. So any point I pick up here is going to be a solution to both inequalities. Okay? So I hope that made sense. We're doing exactly what we did in section 6, 7, but we're not doing it to just one inequality. We're doing it to two, and we're just combining these solutions together. Here's another one, number 18. Let's graph and find the solution set for this. So x less than 4, that would be a vertical line at 4, and it's got to be dotted. And let's see where, if I plug in 0, that's true, 0 is less than 4. So I got to remember for this, I'm shading left. I'll put a little note in blue. I'm shading left of that. Now, y greater than 1. Well, that would be the same as y equals 1, which is a horizontal line at 1, and this ought to be dotted. So there's that. And let me see, if I plug in 0, 0 greater than 1, that's false. So I want to shade above. I want to shade on the other side of the boundary. So for this line, I should be shading above. And then I have one more line here to do. And remember, this is in slope-intercept form. Right now, my slope is negative 1, and my y-intercept is 1. So I start at 1, and so there's my y-intercept. It's at 1. And my slope's negative 1. Down 1 over 1, down 1 over 1, down 1 over 1, and I want a bold line, so I have equals. Let's do that. And for this line, let's try 0, 0. If I plug in 0 and 0, I get 0 greater than equal 1. Well, 0 is not greater than equal 1, so 0, 0 is on the non-solution side, which means I should be shading above this, okay, above this line. So let's see where they're in common. This line said here, the dotted said above it, and the bold said to the right of it. Well, they're all in common up in here, and that's where I'm going to shade. My solution set area is anywhere, any point up in here would be a solution to all three inequalities. Okay, one more to try. Let's go to 16. We have y greater than or equal negative 2 to start. And remember, that's a horizontal line at negative 2, and it's bold because I have an equal. Let's see if I try 0, 0. If I plug in 0, is 0 greater than or equal to negative 2? Yes, it is. 0 is greater than negative 2, so I will. So remember, when I shade, I want to be above this line, so I'll put a little note there, above there. My second inequality was 2x plus 3y is negative 6. Now, just a quick reminder, remember, this is in standard form. And if it's in standard form, I can quickly get the intercepts. I'll just write them up here. The x-intercept, if I plug in 0 for y, cover that up, 2 times negative 3 is negative 6. So you can see how I have a point at negative 3, 0. And then my y-intercept, if I plug in 0 for x, which covers up x, then 3 times negative 2 is negative 6. That's why you can see I had a point here at 0, negative 2. So there's my two intercepts. I got my ruler out. I needed a dotted line because there's no equal here. And let's figure where I shade here. If I plug in 0, 0, 0 plus 0 is 0. Is 0 bigger than negative 6? And yes, it is. That's true. 0 is greater than negative 6 on a number line. So I should be shading above the dotted line also. So I'm shading above the bold line and above the dotted line, and that would be in common. My pen froze. There we go. It's in common all up in this area. I can even scribble up here too. Any of these points above both of these lines would be part of my solution set for number 16. Okay, so one major kind of problem will be what I just showed you. Questions basically 3 through 20 have to do with that, which is taking your inequalities and finding the solution set to that system of inequalities. Now, there's one more thing you'll be asked to do, and this is on page 470. This is completely the reverse process, what I'm going to show you here. If I give you a graph of the system of inequalities, how do you write an equation, or how do you write the system, or how do you write equations for the system? So, for example, when you look at numbers 9 to 20, they gave you the inequalities. They wanted you to graph and find the solution. Now look at numbers 24 to 29. It's the complete opposite. They gave you the graph. They want you to write the system. We're going to go in complete reverse order. So how do I write a system if they give me the graph? Okay. First of all, I put this little note up there. If you look on page 467 and you read carefully, and I know that's a pain. No one likes to have to go to the book and read the example, but I would suggest you stop the video real quick, take 2 minutes, and carefully read through the bottom of page 467, example 3. They show you how to do that process there. I'm going to do it with you on video too, okay? But I would definitely stop the video for a minute, look at example 3, and see that example, all right? So why don't you pause and do that? Okay, so you're back after looking at that. So now we'll do a couple of our own. Look at number 25. And actually, I should just write this out. For 25, let's take a look at the graph. And first of all, look at the, you see the bottom boundary line? It's a horizontal line at y is negative 1. So if I think of an equation, I'm thinking in my mind, well, y equals negative 1. But remember, this is an inequality. We shaded above negative 1. That means if we plug in 0, 0, it must be true. Okay, we shaded above on the 0, 0 side. So let's plug in 0. 0 blank negative 1. What would be true? Well, 0 greater than negative 1 would be true. So there's my first inequality. Now look at the second boundary. It's 1, 2, 3, 4 units up. That would be y equals 4. But remember, it's not equals. We have an inequality. we shaded below 4. So 0, 0 is below 4. So that means I need 0, 0 when I plug it in here to be true again. Now there's nowhere to plug in the x, so I can disregard the x. Let's plug in 0. What would make this true? 0 less than 4 would make that true. Okay, there you go. There's question 25. We just found the inequalities for 25. That would be the system of inequalities for number 25. Okay? There's no x plus 1y greater than -1, no x plus 1y less than 4. Let's do 27 also. I just flashed it up there. I'd rather kind of walk it through you. Okay, so 27. Now this time they have 2 lines. Well, this should be easy. Now remember, this is a good review. If we're talking lines, we're talking linear, right? And if it's linear, we can definitely use slope-intercept form. So let's talk about the dotted line you see first. So I'm going to take a close look at that dotted line, and the first thing I notice is it's crossing through the point 0, -2. So let's talk about I'm going to write it up here, dotted line. Okay. Can you see that the y-intercept on the dotted line is -2? Okay, it's 2 units down on the y-axis. So I know b for the dotted line is -2. Now let's get the slope. Let's start at -2. It looks to me like if I go up 1 over 1, up 1 over 1, up 1 over 1 each time, that there's my slope. It's up 1 over 1. Well, when I think about my slope as up 1 over 1, that means my slope's +1. So I guess I can put a 1 there. And now here's the last thing. I don't want equals here. It's a dotted line. You notice how the 0, 0 side of that dotted line got shaded. That means if I plug 0 in here and 0 in here, I got to get a true statement. So let's see what would give me a true statement. 0 here is -2. Is 0 greater than -2 true, or is 0 less than -2 true? And I think you're probably coming up with, well, 0 greater than -2 is true. So there's the dotted line inequality. Now let's get the bold line, because there's a second line. It was bold. And okay, we're going to use, again, it's linear, so I have y equals mx plus b. All right, so let's get b first. It looks like on the bold line, b is 1. My y-intercept for the bold line is 1. So b is 1. Okay, can you see that on number 27? And then let's get the slope. Well, this is kind of harder to tell. I got to work backwards. It looks to me like I can't count up and over because it runs out of space. Let's go down. If I go down 1, 2, 3, 4, 5 down and 1 left, 5 down, 1 left, there's my slope. So that would be the equivalent of going 5 up, 1 right. My slope is 5. So go ahead, take your pencil and look at that point 1, -4. If you take your pencil and put it on the point 1, -4, and you go 5 up, right 1, you get to the point 0, 1. Our slope's 5. So I know the slope is 5. And now, if you plug in 0, 0 in comparison to the bold line, do you see how 0, 0 is on the shaded side of the bold line? That means 0, 0 must be a true statement. Let's see what's true. If you put a 0 in here and you put a 0 in here, you get 0 and you get 1. Well, 0 less than equal 1 would be a true statement. I got to have an equal in there. It was a bold line. Okay, well, there you go. We just found our system for that system of inequalities. We just wrote inequalities for them. Okay, so I did 25 together with you there. I'm just seeing if there's anything, and I did 27 there. I just wanted to make sure I'm not missing anything. And that, yep, I've covered everything I think I want to cover in this video then. Okay? We can go over other questions you might have tomorrow, but I hope that gets you through what you need to do to get going on this in class tomorrow. Like I said, any other questions you might have, we can talk about then.